Hello everyone, my name is Tasneem Safdari and in today's video I am going to explain question number 5 of end sem paper. So let's start with question number 5. I have explained question number 1 to 4 means in separate videos which is uploaded on my YouTube channel. You can look to it for its explanation. So let's start with question number 5. We will discuss question number 5 both part A and B in this particular lecture, and next that is question number 6 to last we'll discuss in next videos. So question number 5 part A, distinguish between parametric versus non-parametric models, supervised versus unsupervised learning. So what is parametric and non-parametric model? So parametric model assumes a specific functional form for the relationship between input and output. So it assumes a specific function which defines the relationship between input and output, and it makes no assumptions about the form, learns the relationship from the data. So from the data set which we have, it will learn the relationship from it. It do not assume any relationship before. Number of parameters, fixed, independent of data sets, and variable, can grow with data set size. Less flexible, may fail if the true relationship is complex. High flexible, can model complex relationships and can perform well with small data sets. Require large data sets to achieve good performance. Generally faster and less computationally intensive, can be slower and more computationally intensive. Easier to interpret due to fixed parameters, often difficult to interpret. Non-parametric, because we do not have a function to define input and output, so often difficult to interpret. Model structure adapts to data. And then risk of underfitting if model assumptions are incorrect. So underfitting, there is a risk of underfitting if we do not make assumptions, if assumptions are incorrect. And risk of overfitting if model is too flexible or data is noisy. Examples are linear regression, logistic regression, naive based polynomial regression. And here k nearest neighbor, decision tree, kernel density estimation, Gaussian processes. When to use parametric? So when you have prior knowledge about data distribution or small data sets, when we have prior knowledge about how data is distributions or small data sets, and when the data relationship is unknown or highly complex. Then supervised versus unsupervised learning. So supervised learning from labeled data, we have input output pairs. And unsupervised learning from unlabeled data, no output labels, predict outputs or classify inputs, and discover hidden patterns, groupings or structure in the data. So supervised learning goal is to predict the outputs or classify new inputs, and in unsupervised learning discover hidden patterns, groupings or structure in data. Requires labeled data set. Supervised learning requires labeled data sets, and unsupervised learning works with unlabeled data sets. Then learning function, learn mapping, like f of x is y f of x to y f of x to y. And learn the structure or distribution of input data, that is xx. Now predict values, that is regression, or classify labels, that is classification. And clusters, here it is cluster association or dimensionality reduction features. Then here it is accuracy, RMSE, F1 score, precision, recall. And here it is Silhouette score, explained variance, clustering, quality measures. Then example is linear regression, logistic regression, random forest, support vector machines. And here it is k-mean clustering, hierarchical clustering, principal component analysis, that is PCA. And applications are stock prediction, spam detection, fraud detection, medical diagnostics, customer segmentation, anomaly detection, feature extraction, data exploration. Complexity can be simple or moderately complex depending on model, and can be computationally intensive depending on the method and data size. Usually interpretable, especially for simple models. So we can interpret it when we have small models, and often harder to interpret, especially in clustering or high dimensional reduction. So this was part A, where we have discussed parametric versus non-parametric models, as well as supervised versus unsupervised models. So we have made a difference based on different criteria. So this was part A. Now let's move to part B. So with reference to text mining, describe accuracy, precision, recall, F1 score, and illustrate their computation using a confusion matrix. So confusion matrix compares actual labels with predicted labels. So we have actual positive, actual negative, predicted positive, and predictive negative. So we have used the example as spam and not spam. So actual positive is spam, actual negative not spam. Here model says spam and model says not spam. So we have true positive, false negative, false positive, true negative. So meaning of each term: true positive, these are emails that are actually spam and the model correctly predicted them as spam. Correct detection of spam messages, which is done by true positive, which says that the emails are actually spam and the model correctly predicts the spam. False negative, emails are not spam but the models wrongly predicted them as not spam. This is dangerous because spam goes undetected. So model fails to predict that it is spam. False positive, the emails are not spam but the model incorrectly predicted them as spam. This causes important emails to be mistakenly flagged. Then true negative, emails are not spam and the model correctly identified them as not spam. This is perfect. Normal emails remains in inbox. So using the confusion matrix. Accuracy measures how often the model is correct. It tells you out of emails how many were correctly classified. So accuracy is TP upon TN, which is the true upon all of them, that is TP plus TN plus FP plus FN. So consider all correct predictions, that is TP and TN. But accuracy can be misleading when data is imbalanced. Example, very few spam emails. So at that time accuracy becomes it can be misleading. Then text mining meaning. In email classification, accuracy shows that overall correctness of the spam filter. Now precision. Precision answers this question. When the model predicts spam, how often it is actually spam? If it is predicting spam, how often do we really know that it is actually spam? So formula is precision equal to TP upon TP plus FP. So out of all emails the model marked as spam tell us how many were truly spam. So it tells that how many were actually spam. So it penalizes false positive. Cases where normal emails were wrongly marked as spam. There were cases when the emails which were of use were also marked as spam. So text mining meanings. High precision means the spam filter rarely works a normal email as spam. User don't miss important emails. And low precision means many genuine mails are incorrectly filtered, frustrating for users. Recall. So recall answered this: out of all actual spam emails, how many did the model successfully detect? How many were they actually able to detect? So recall equal to TP upon TP plus FN. Really, recall focuses only on positive class spam. It penalizes false negative cases where spam slips into the inbox undetected. So high recall means the model catches almost all spam, and low recall means the model misses many spam messages, which is dangerous. F1 score is combination of precision and recall. It is harmonic mean which gives a balanced score. Formula F1 equal to 2 into precision into recall upon precision plus recall. Interpretation. F1 score becomes useful especially when the data is imbalanced, like spam versus not spam. It balances precision, how accurate positive predictions are, and recall how many positives the model found. Text mining meaning. Good F1 score means the model catches spam efficiently and rarely labels normal emails as spam. It considered one of the most reliable performance indicators for spam detection. Complete understanding. Accuracy, it was TP, TN means overall correctness, good for balanced data set. Precision, how trustworthy spam predictions are and important to avoid losing important emails. Recall, ability to catch all spam, important to block dangerous spam. And precision and recall means balanced performance based, which is F1 score, which means balanced performance best for imbalance cases like spam detection. So this was all about question number 5 part A and B. We have discussed both parts in detail, and the remaining parts question will be discussing in the next videos. I hope you liked it. Thank you so much for watching.